Hey everyone, this is Derek, and in this video we're going to look at the definite integral again, but this time as area under a curve, rather than just sort of this idea of anti-differentiation. So area in the definite integral. So if f of x is a continuous non-negative function, so non-negative means on some interval a, b, so on whatever interval I'm going to look at, we're only going to look at functions that are above the x-axis. We can have things that dip below, different situation, different video. So in this one, we're going to only look at the ones where it's non-negative. The area A bounded by the function f of x, the x-axis, and the vertical lines x equals a and x equals b is equal to the value of the definite integral from x equals a and x equals b. So what that means is if I have some curve, in this case I'm using a straight line because it makes math easier, and I want to look between 2 points, say on this one between 0 and 3. Say that's my interval. This is always either 0 or greater than 0 on this interval, so I can do this. If I do the derivative or the integral of this and integrate from 0 to 3, that should give me this red area under the curve. So that is what this is saying. And this is just the fundamental theorem of calculus that we saw in the last, where we do our integral and then we plug in our a and our b, we do our difference, and that gets us that value. This is what we're finding is this area. So if I just look at the triangle, and my function I'm using here is 2x, so if I put in 3 in there, I get 2 times 3 is 6. So this triangle would be, the area would be 1/2, and then my base is 3, and my height would be 6. So that is half of 18, so my area should be 9. So now if I treat this like a calculus problem, I'd be finding the definite integral from 0 to 3 of 2x dx. That's what this is saying. I can also find this area this way. So if I do that, this will be x, remember it's 1 plus 1 over 1 plus 1. So that would be 2, I'll go ahead and show that part, 2x squared over 2, evaluated from 0 to 3, which those 2's cancels. Now we can just do x squared evaluated from 0 to 3. So that's going to be 3 squared minus 0 squared. And that again is 9. So you can see I'm getting the same thing either way. For finding the area of a triangle, this is not that exciting. But if we're trying to find the area under some crazy curve from here to here, that starts getting a lot trickier to figure out what that area would be, right? And now if this function, whatever this is, if I can find its antiderivative, then I can use this to find that area. So why would I ever want to find that area? Okay, so this is also a good question. Let's say I drive for 4 hours. So we'll just go 1, 2, 3, 4 at a constant speed of, say, 70 miles an hour. And so that's what, if I want to sort of, this would be my graph, is my constant speed. So this is my miles per hour, and then this is in hours. So what would the area under the curve be in this case? 4 times 70, right? Because it's just a rectangle, 280. So what is that? That is how far I drove, right? If I drove 70 miles per hour for 4 hours, I drove 280 miles. So this idea of the definite integral being something, a mechanism of accumulation, what it's accumulating is this area under the curve, and what that is going to be that top value in your rate. And the reason is because we're going 70 miles per 1 hour times the bottom is hours. So we're ending up with, that should have had a 4 hours, and that's our 280 miles. But when we're integrating, what we're doing is we're getting back to that value. And on something that's, like I said, a straight line like that, easy. But when we have these curvy things, this allows us to do some pretty clever math to get that information. Okay, so this is the first one that actually kind of looks like the homework. And so all we're going to do here is we're going to integrate from 0 to 2 this function. So we'll go 0 to 2 of 6x squared minus 3x plus 4 dx. And this will be, show my steps, 6. 2 plus 1 would give us 3 over 3, and I'll reduce here in a second. And then 1 plus 1 would give us 2 over 2. And x to the 0 plus 1 would be just an x over a 1 essentially. And then that's going to be from 0 to 2. Reducing that just a little bit to make it slightly better, we'll go 2x cubed minus, nothing to be done there, 3/2 x squared plus 4x from 0 to 2. So it's always nice when there's a 0, because now when I go to do the subtraction, I get 2 minus 0 times all that. So it just ends up as a 0. So this front part's going to be 2 and then 2 cubed minus 3/2 2 squared plus 4 times 2. And I'll just show the second part as minus one big old 0 as those all get knocked out. 2 cubed would have been 8 times 2 is 16. This would be a 4, but then that 2 cancels one of those 2's, so it'd be 2 times 3 would leave it minus 6 there, and then plus 8. So that should be 18. And so what we found is basically this curve. If you graph it, it would look, oops, it would not look like that. It would look something like this. And we just found the area under there. That was 18 units. This one's very similar. We're just using a different function. So for here, we'll do our integral from 0 to 2 again of e to the x plus 5 cubed. So remember, when it feels a little bit like chain rule, then in terms of integration, that means it's probably going to be a u sub, and that would be a dx. So let's let our inside part be u. And then our du, remember the derivative of e to the x is just e to the x. A derivative of 5 drops out, so that's dx, and that's exactly what I need there. So now I have 0 to 2, that's going to become my du. This was now u cubed, and then du. Once we got that, we'll do our integration. So that's going to be u to the 4th over 4, evaluated from 0 to 2, which is, u is right there, so that's going to be e to the x plus 5. Okay, my neighbor started pounding on something, so hopefully that has stopped. And I added a 4 right there. I forgot to write that 4 when I came down. So evaluating this, we're going to go e squared plus 5 to the 4th over 4, and then minus, and you gotta be a little careful when this is 0. It does, like the last one is nice, it all dropped out, but this one it doesn't, so we do have to actually do some math with that. E to the 0 and then plus 5 raised to the 4 over 4. And then all that I just threw in a calculator. And the directions on this one were round to the nearest whole number. And so after tossing it in the calculator, I got this. And then so to the nearest whole number would have been, oh, and that was this piece, and then minus 324. And then I got 555, 66 to the nearest whole number. Okay, so this one we're doing from 6 to 10, and x over x squared plus 8 dx. And so here we're going to let u, because it's a fraction, so we'll let u be the denominator, because that has the higher power. And now that makes our du 2x dx, which is close. We got to get that 2 out of there, so let's make that 1/2 du equals, and half of that would reduce it to x dx. And that's what I'm going to have left over when I do my substitution. So now we're going from 6 to 10, oops, of, that would be 1 over u du. And that's going to give us a natural log. So that will be, oops, I'm sorry, I forgot my 1/2. I should have 1/2 right there. So that'll be 1/2 of ln of u evaluated from 6 to 10, which is 1/2 ln x squared plus 8 evaluated from 6 to 10. And so now we just need to toss that in the calculator. In this one, I think they wanted the exact solution, so let me show you what I did. So I did 1/2, and then that 1/2, I'm just going to times at the end so I don't have to carry the fraction through the parentheses, so it's kind of like I'm factoring it out front. So this will be natural log of, these are both positive, so I don't have to worry about the absolute values. This will be 10 squared plus 8, and then minus natural log of 6 squared plus 8. And then doing that, 1/2 ln, that's 108, minus natural log 36 and 8 would be 44. And then this I can write as 1/2 natural log, because that minus, remember we can do a over b on this, so this is 108 over 44, and then that fraction reduces a little bit. So natural log of, I think I can knock a 4, yep, a 4 out of both of those. So 27 over 11. And on that one, like I said, they want the exact.